Okay, guys, in this lesson, we're going to be talking about how to write a quadratic equation given particular data points. We're going to take a look at function tables, and depending on what data points we're given, writing the equation either in standard, factored, or vertex form. And then we're also going to take a look at parabolas, the graph of quadratic functions, and write those in the different forms. So it does depend on what pieces of data are given. For example, do we know the y-intercept? Do we know the x-intercepts, the vertex, etc.? And that will determine which of these forms of equations we will use. So we are going to take a look at function tables for case 1, case 2, and case 3. And then our last case, case number 4, we'll take a look at a graph. So let's begin with case number 1, and I'm going to teach you when you would write in standard form. So in order to write in standard form, we will need some consecutive ordered pairs. And when I say consecutive, I'm talking about the x values are consecutive. So for example, we have -1, 0, 1, 2, and 3. These are consecutive. The second piece that we have to know is the y-intercept, and that's when the x value is 0. So we do have our y-intercept. So now we need an A value, a B value, and a C value to write standard form. So we know that when we are given the y-intercept, when x is 0, this value, the y-coordinate of the y-intercept, is our C value. So again, we're going to need an a B, and a C value, and we know our C value is -2. Now let me show you how you find the A value. So again, to find the A value, we're going to want X values that are consecutive. So when our X values are consecutive, we can just focus on our output values. So to find the A value, we're going to find what's called the first difference. So that means we're going to find the difference between the outputs the first go around. So from -5 to -2 is a change of 3. So that's the difference between these two outputs. And then from -2 to 7 is an increase of 9. 7 to 22, that's going to be an increase of 15. And from 22 to 43 is an increase of 21. This is called the first difference. We're just taking the differences of the outputs the first round. Now we're going to find what's called the second difference, and we're going to find the difference between the first differences. So from 3 to 9 is a change of 6. From 9 to 15 is a change of +6. And from 15 to 21, the difference is a +6. So this is called the second difference. Now, on the second difference, when it is constant, when it is the same, this tells us that we have a quadratic function. So that's one way to identify if a function table is quadratic or not. Now let's get to the purpose, the second purpose of finding the second difference. So the first purpose is to identify that this is a quadratic function. Now we can take the second difference value. This is going to help us find our A value. So the second difference is divided by 2 to get our A value. So our A value for this equation is 3. The C value is -2. So let's make sure that we write a formula to get the A value in standard form. Is we take the second difference and we divide it by the value of 2. So I would write this in my notes. I would also write showing how we find the first difference. negative 5 to negative 2, that's a positive 3. Negative 2 to 7 is a positive 9. So these are all increasing. And then to find the second difference, you take the difference of the first differences. Then to get the a value, you divide that value by 2. So let's write what we have so far. Y equals 3 times x squared plus some b value we do not know. And then we have our c value of negative 2. So now we have the a and the c replaced, and we need to find the b. So anytime you are left trying to determine one piece of a function in the equation form, we can simply pick a point that we've not used. We've already used the y-intercept, so we're going to exclude that point. But we're going to pick any other point to plug in for x and y into our equation. So I'm just going to choose 1, 7. So everywhere I see an x, I'm going to put a 1. And everywhere I see a y, I'm going to put a 7. So I'm going to take 7 equals, because this parabola passes through each of these points. So any of them will, quote unquote, work. So we have 3. I'm going to input 1. Everywhere I see an x, I'm going to put the 1. And now we have every variable with a value except the one we're trying to identify. So now we're just going to go through and apply our math properties. We're going to do order of operations. I square 1, that is 1, times 3 is 3. B times 1 is plus 1b minus 2. We're going to combine our like terms. So we have 7 equals 3 minus 2 is 1 plus b. Now we are going to solve for b by isolating, and we're going to subtract 1 from both sides. And our b value is 6. Now we can replace the b value. So our a was 3 times x squared plus our b value is 6 times x minus 2. So here we have our equation in standard form. If we wanted in vertex form or factor form, we could apply those skills. So that is how you find the equation of a quadratic function when we're given a table of values. 2 things have to be true. Our x's have to be consecutive. That will help us get our a value, our second difference divided by 2. The second criteria is we have to have